Okay, so cold theory, great question the other day that led to this. So it's, I realize I didn't remember the word constraint. Constrained optimization with limited deviations. Well done. So we've got hot. Let's make a cold model. And let's make, it's not just for fun. It's actually a little bit more serious than that. It has a nice, it has an important extra step in here. So we're going to just kind of punish or depending on how it's created or whatever, tested, we're going to sort of we're going to be worried about large ones, right? We're going to weight them a little more heavily. So we're going to sort of simply punish the evolution algorithm, not punish, but we're going to make it favor moving away from any large thing. So what that does mean, as I said the other day, this is going to mean the average forest fire, for the forest fire example, is going to be larger, but you'll never get a gigantic one. So it takes away the chance of catastrophe. Okay, that's a Mark Newman paper. We're going to talk about Mark a fair bit. Yeah, so what you end up with, do I have it? Yes. This is the sort of thing maybe I haven't said this enough. This is a very typical kind of form that you get out of a lot of systems. There's a power law decay and then an exponential. So a product of a power and an exponential. You see that very explicitly. It's a different kind of thing, but for gamma distributions, this is a positive thing and then exponential. This may not, you might think, I think when I first saw this, I thought, well, this is sort of the dominant piece in here, right? This exponential, that should just kind of crush this thing. But if this XC is very, very large, right, 10 bazillion, then, and your X is starting, it's sort of order 1, it takes a long time for this exponential, even though it's an exponential and it goes like this, it takes a very long time for it to start to kind of really get into its decay. So if this is very, very large, then it's going to take a long time. And then when X is of that order, when it's similar to X sub C, this starts to dominate and then it dies. And so on a log-log plot, what you see is this thing with a nice gamma, right, minus gamma, it's going to have this power law and then go and fall off. And where it falls off is around here. So the framing for this is exactly, it's power law size distributions with an exponential cutoff. That's what that means, an exponential cutoff. So in our assignments, we've just sort of said, there's a beginning and end, there's this a smaller scale and a larger scale, and it's a pure power law in between. This is a much more common kind of structure, and it comes out of theory and it fits observational stuff. So good thing to know. And there are other pieces I said, so Weibel distribution, so it could be this sort of thing. The Weibel distribution is a special little character where when you've got the right exponent, it collapses back to being, right? So when gamma is 1, which is a funny sort of thing, it's not going to work out. It would clap, I'm saying the wrong thing. Yeah, when gamma is 0, then this is e to the minus x, right? So it has the exponential as a special case in there, and then can vary around. Okay, so we're going to talk about this later on when we get to networks, but it's error and attack for complex networks, so it's sort of another part of robustness. This is early work, this is 2000, but and then we'll talk about contagion and so on. So we'll see some really, I think, kind of shocking stuff really for threshold models of social contagion where everything looks like it's fine, but if it gets hit in the wrong place, the wrong person in a sense starts things off, or the wrong small group of insignificant characters kind of start the wrong thing off, the whole thing can explode. So, which is very important to kind of understand, like, how do you get these massive transitions in society that, have happened in the past? We've got all this historical evidence. How do those things happen? Okay, I'm not going to show you that. All right, so it's Robot Chicken where the emperor falls apart mentally. Anyway, so it's probably a little too much. You can enjoy that your own time. Okay. But this robust yet fragile thing, we put into stories all the time. I had the 1 in a million thing the other day, Smaug, Tolkien, right? There's one scale, there's always, there's always like, there's one button you have to reach and it turns everything off. It's a convenient thing. But it's also, in Achilles, we mentioned that as well, but it's also actually true of some real systems. A squirrel eats the wrong bit of a power grid and it all explodes. All right.